Hello, this is loud, good. I'm Chris, I'm working at Microsoft on JavaScript engine and JavaScript editor. That's why when they asked me to come to this conference, they asked me to talk about CSS. Because nobody else wanted to, it seems. And this is what I really want to talk about today, that as a web developer that I've been for 20 years now, it's always quite bizarre how CSS versus JavaScript is this constant battle that we're having here. And I wanted to remind you today about a few things that CSS has caught up with that might be interesting for you to use, and to actually stop belittling it. There's so many things where you're like, every time there's a talk about CSS, there's this Family Guy animated GIF with like him trying to get the jealousy up and like, oh, everything is so hard and so tough to do in CSS. And I get kind of tired of this because this bickering that we do between different fractions of our market doesn't help anybody. In essence, we have to build things for users, and what we use to get there is what made us effective, but is also good for the end user. So yesterday night I went here and I first of all realized in the Netherlands you get South Park Studios, which is cool because in England we don't get it. Why, I don't know. But also on Netflix you had this Civil War Captain America movie, and I already got bored with that on the plane, so I thought I might get bored with it at home again and see what it's about, if it's even better, or if it just was me not liking it. And I still got bored by it. Because the problem with a movie like that is that Marvel introduced 10,000 characters that they all want to make an extra movie from, and then all of a sudden it was too many and we didn't remember anymore who was who and what was going on. So they're like, hey, let's make a movie where they're all discontent with each other and then they fight with each other at an airport and kill all kind of airplanes and delay my flight and do all kind of things together. And the whole fight was boring as toast because they were all matched. They all had the same powers, they all had the same thing, they all were friends, they were all working together. I knew there's not gonna be like Captain America cutting off Iron Man's head and go like, ha ha ha, there you go, you know? Because it was a PG-12 movie as well, and I was just like, what is all this aggression for if there's no end point to it? And this is exactly what I feel when we're talking about JavaScript or CSS or whatever other thing we do to get something onto the screen. Because all of those have powers that are different to the other technologies, and all of them should be used to their best use case rather than just because using it. So CSS seems to be confusing for programmers, and that has been since we invented it. I mean, I did 1997, I looked the first time like, why do we do this BG color thing and table layouts? What can we do? And back then it was like, make your websites faster with CSS because the look and feel is only in one file that can be cached by the browser. And we're like, oh, this is so cool. And people then like 5 years later, you still think this is cool? This is really nothing that's going on what we do. Look what I can do with React. But I love this tweet the other day where she's like, can these two groups, CSS is so easy, it's not even coding, CSS is so hard, we need to replace it with JavaScript, please talk to each other. And this is sometimes the same group, because we look at CSS as developers and we find the syntax weird, like exclamation mark important means it is important. As a JavaScript developer, I'm always stumble over that one. It's kind of odd. Everything is a string, everything is basically a declaration, and I'm just standing there, what's going on? And then we do what every developer does. We change stuff and seeing what happens. And we mess things around in CSS, and when the display doesn't control it properly, then we actually say the language is terrible and should be replaced by something useful. Like, for example, OpenGL. I love that one. OpenGL, show me, and then you got like the triangle with the colors there. And a lot of times, every time I talk to people that come from higher level programming or games programming on the web, they're like, why can't I use GL for that? And I'm like, because you don't know the operating system, you don't know the processor, you don't know where this thing is gonna run. So something like CSS is much more forgiving and much more sensible in an environment that is undefined. But it's kind of weird for us to do that because we don't want to give that control away. And this is what the whole fight is about. Controlling the environment, controlling the display. So if you think about it, CSS is fault tolerant. And this is like everything on the web. HTML is fault tolerant. If you do something wrong in a CSS file, the parser skips that line and says like, well, let's look at another one, I don't care. If you do a JavaScript error in one of them, the JavaScript processor, I don't play with you anymore, I'm gonna go in the corner now and not talk to you. So CSS and HTML is meant to allow the publisher, is meant to allow the person writing it to make mistakes without the end user being punished. And as a developer, that always feels weird because we want to know at least why, or get some console log or some stack trace, what happened. But CSS is kind of silent when it fails. We just know it failed, and that's about it. So it can be confusing for developers that want to control everything, but it's actually great for people who think, okay, if I made a mistake, it's not my end users that have to suffer from it. It's my job to find out what's going on. And that's why if you use a proper editor, you have CSS linting in the editor as well, and you have insights of even hovering telling you what these things mean. I use Visual Studio Code because I'm part of that team and I work on that. And we even have a nice extension now that tells you when you run over a CSS, which browser support it, instead of having to look it up every single time on the web. And this is what we think we should be going to. We should be starting more about linting than debugging. Before we write stupid code, why go through all that and then find the error? Let's prevent us from writing the error in the first place, much like we have like thesauruses in something like a word. So basically every time you write a word wrong, you get a squiggly underline. This is what we should be doing for coding more as well. JavaScript is not fault tolerant. That can be disastrous. That's why you get these web pages that are empty. That's why you get endless spinners on the web. That's why a website tells you, oh, you're not on Chrome, you're not on a MacBook Pro, sorry, no internet for you. And this is not what the web is about. This is not what the web was meant to be. And let's not start with the UK government trying to censor it. That's a different story, but I can talk about that for hours as well. So in CSS, you apply your styles and you hope it worked. This is actually all you have. And this is kind of cool because it's up to the end user to see something that makes sense. So your CSS should never be in the way of the end user. We had a big problem when we had CSS prefixes. Out of a sudden, we had buttons with white text and white background, because the background was a WebKit gradient that only worked on the first iPhone. So there were buttons by the dozens on the internet, by the 100,000s on the internet, that were completely unusable for somebody not having an iPhone, because the developer was too lazy to just define a background color and then overwrite it with a gradient only when the browser supports it. And this is what you should be thinking about CSS all the time. It's an enhancement to a user interface. So if you do layout with CSS and the thing stacks up in a sensible order when the CSS could not be executed or is not supported by that browser, great, you've done nothing wrong. You built an interface. You built a sensible interface. You didn't build something that is perfect for everybody, because that doesn't work. I always compare it with escalators versus lifts. Escalators, when they break down, they're great because they're stairs. You can still go to the other level. It takes more effort, but you're not stopped from getting to the other level. On a lift, you stand in a room that is broken with 5 people you don't want to be in. So escalators are there to accelerate our way to something. That's my favorite at airports, when you got the walkways and people stand on them and they're like, these things are meant to make you move faster, not to make you move. Get out of my way right now. That might be just me. In JavaScript, however, you control the styling and you can and should verify that it worked. As soon as you make an interface and you make it dependent on JavaScript, it's up to you to make it available for people. It's up to you to understand what to do when something goes wrong. And it's not telling the user to please download another browser, because that's what we did in 1996. That's why we have malware on a lot of computers right now, because people didn't get rid of those old computers and those old browsers that everybody had to use. Now, CSS means embracing the squishiness of the web. I love that term by Brad Frost, where it's like everything is squishy. You have no idea about the resolution, you have no about the pixel density, and so on and so forth. I'm actually listing this right now. So here are the things that are beyond your control on the web, and there's nothing you can do about it. You can stomp your foot, you can get very angry, you can tell your users that they're idiots, but it's not a good business idea. So the browsers of your users are not in your control. Every time you say like, oh, people should just upgrade, go on holiday and go to a holiday like reception and try to print out your tickets on a Mac from 2003 that hasn't been changed since then. You have a better computer at home, but you then don't have it with you. In older Android phones, you got a shitty browser that you couldn't remove or could replace with something else. There are environments where you cannot control the browser, and you cannot tell people to use a developer browser ever. That's like 0.02% of the market. The resolution, the pixel depth, the color settings of their devices, you don't know that either. Their connection reliability and speed. Like, oh, it looks great in our office, and then you try it on a 3G phone, and you're like, oh, I just waited 50 seconds, which nobody does on a mobile phone. 3 seconds is all you have. Then people will either punch their phone or tell you that I'm going to use the competitor. The connectivity restrictiveness, resources may be blocked. Like, I mean, there's ad blockers, but also on mobile, on cheaper mobile connections in England, they might actually minify your JavaScript without telling you. The mobile phone provider does that, and the CSS provider does that as well. So your code gets changed by a man in the middle without you having a chance to change anything about that. There are font size and zoom needs. Like, I'm getting older as well, I need bigger fonts. You cannot tell me like 12 pixels is enough, especially not when I'm Chinese and the lettering is like this big. This doesn't work. The availability of resources on their machines for your product. Is the CPU already burning? This is happening all the time. People are like, oh, this computer, your website is so slow, while they're actually running some WebGL renderer and like all kind of conversions in the background. The amount of text content and image sizes in your product, because we always build these great things that look great, and then we give it to a content management system, and people write like treatises and put like James Joyce Ulysses in a headline and like upload BMPs and these kind of things because they haven't been trained, because we think maintenance is done by people that should not get paid much, which is why they break all our products all the time. So in CSS, it's the job of the browser to perform well, use GPU resources, and skip functionality. So a CSS animation that isn't smooth gets cut off by the browser, and then is not an animation, just goes to the end of the animation. Your own JavaScript animation, for example, it's your job to test for support, to ensure that rendering, painting, and reflow is fast, and to keep your animation in sync. You have more control, but you have much more responsibility as well. And this is not a responsibility we can go away from. We cannot tell you our users should be upgrading and should be better there. We're a delivery service. We get paid a lot of money to do this. So when somebody whines about our end users not having the right browser, and I'm like, what are you getting paid for? You're not getting paid to be more effective. You're getting paid to actually build something that works, so people click on ads, so people buy things, so people pay our wages. So our job is to build interfaces that work. So why do we constantly underestimate CSS and overvalue the benefits of JavaScript? I have no idea why that might be. Might be a historical thing, I don't know. It is that in the olden days, browsers were, what's the technical term? Shit. And they basically didn't follow a standard. There was no standard that they could follow, and they competed with each other on making things only for our browser. And these things never went away. So these things are still on the web, and people still do support them, although they should not anymore. Internet Explorer is dead, and basically good riddance. Don't give it anything it can't swallow. Give it HTML, a bit of basic CSS to display something on top of each other. If the main use case of your website works in those old browsers, people are happy. Don't give Internet Explorer 6 users beautiful interfaces. It just confuses them. They're not used to beauty. They're not used to interactivity. They like their drop boxes and their radio buttons and hope that when something clicks, something happens. All the internal systems we have to use in Microsoft, for starters. So CSS had a bumpy history. It initially was very limited and was just there to replace things like background color and font elements and like table layouts and aligns and centers and HRs and all the things that are graphical and HTML, which should have never been in HTML. And then we had patchy browser support and very odd errors without debugging options. Debugging back then was put an alert on everything and hope you find some information out of it. We didn't have developer tools like we have nowadays. We had a massive jump in functionality when iPhone became a thing and Apple called the shots. When Apple said like HTML5 is the future and here's all the cool stuff that WebKit can do in CSS, cool, I was really excited. I was really pissed off as well because it wasn't standardized, but it was everything only for WebKit. So when we released Edge, when I was part of that team, we had to put a lot of bugs of other browsers in a new browser not to break the web, because developers relied on experimental functionality. When something had a CSS prefix, you got no control over that. That company can completely change the look and feel and functionality of that, and you have to keep up. That's why it's called experimental. In experiments, people die sometimes. We don't. Pixels get shifted around, but it's still a weird thing to rely on. And lots of problems with browser wars around prefixes. So, oh, we have this, you should use our browser. Our browser does that, you should use our browser. And so, luckily enough, all browser makers grew up about this, and we realized that killing each other is not going to happen. Browsers are not important. Nobody makes money with a browser. Have you ever paid for a browser? Okay, Opera was a browser you had to pay for. Sometimes like an ad blocking browser on a mobile phone people would pay for. But browsers are a means to an end to bring services to end users. Chrome is not by Google because they want to sell a browser. It's for you to use Google services and get search results, and they get money for showing search results. It's a way for you to use services of Google, much like Edge is that for Microsoft, much like Safari is that for Apple. Browsers are there to display content, so it doesn't matter what you think is the best one. People will probably use the one that comes with their machine, and none other. They don't even know what a browser is. Up until now, recently, there was no layout modules. So we just used hacks by positioning and absolute positioning or floating, and that was always a very confusing point for people who are not graphically inclined. And absolute positioning was easy, but absolutely terrible, because as soon as you changed the font size and you didn't use EMs, everything overlaid each other and you couldn't use the interface any longer. So our solution was always to patch with JavaScript, because in JavaScript we had the control we never had in CSS. I can read out how wide the browser is. I can even read out what font size was used. I can read out the color. I can use generated content. I can use all things to know what's happening. And JavaScript has this wonderful if statement, where it's like, if it worked, then show it. If not, do something about it. In CSS, this if statement is always implied for the browser by us. So we created HTML, and we applied styling, and we did all kind of fixes. We had all the polyfills that, like, when one browser had functionality and the others didn't, we put the polyfill in so all of them had the functionality, but we never took the polyfill out when these browsers ceased to exist or even being supported. That's why we have lots and lots of JavaScript on the web that's unnecessary. But CSS has been going leaps and bounds in the last few months and years, and a lot of times we just gave up on it because we just see this common denominator of the specter of IE9 and everything else is not usable yet. So evergreen browsers are a thing, and they're a very important thing. Something like WannaCry and ransomware shows me that we have to keep our software up to date all the time, because the bad guys are faster in abusing it than we are in supporting it. Browser tooling gives detailed insights. I mean, I get heap analysis, I get stack traces, I get everything in browsers nowadays. I know why something is slow, I know why something wasn't applied. Support is well documented. CanIUse.com is your friend. This is a really, really amazing website that shows you which browser supports what and why it doesn't support it and what the errors are and where to bitch that people should fix it. So don't go on Twitter and say like, oh, this browser is terrible, the other one is better. Go to these bug references. Go file a bug. Go upvote a bug. Go upvote a system, because that's where our engineers are sitting of all browser makers. Support channels and bug tracking is available for almost all browsers. I'm saying almost all browsers. I'm not mentioning names, but Apple. We have pre-processors like SAS and less, which have turned up the heat to innovate the spec faster. Most CSS people that are only excited about CSS went to less or SAS quite some time ago, because you had mixins, you had variables, you had all kind of really cool stuff happening in there. And much like jQuery made us revisit and rethink what JavaScript can do nowadays, these pre-processors made us rethink what CSS can do as well. On Friday, there's CSS Day here actually in Amsterdam, so there's lots of good information coming out there. Approaches like OOCSS by Nicole Sullivan and Atomic Design by Brad Frost allowed with more maintainability of different components as well, to make CSS more maintainable in a large scale, rather than like a lot of repetition, a lot of problematic things that CSS was there. Because it's really easy to write a lot of CSS that doesn't get applied, and there's lots of tooling going around that one now. So I just want to list a few amazing things that CSS can do now and that you should consider using. And even if you don't consider using it, know that it exists and partner with somebody who likes CSS and likes doing layouts. The biggest mistake that I always find with CSS is that everybody complains about it because we're asked to do it. Just say no. Just say, hey, I'm a database administrator. I'm like a full stack developer. What the hell should I have to do with CSS? This is something an interface person that cares about interfaces and knows users and knows browsers should do. We have, if you get fired, Microsoft is hiring. You know, like we have nothing to lose right now, but we try to take on all the jobs that are not ours to do. So why should you give yourself that grief that you don't want to play with? Simple things like calculated CSS values. You probably heard about this, or put your hand up if you haven't yet. It would be interesting to see. It's, say for example, you have an input box where you want to have the input box to fill the whole thing and also have some padding around. And you also have some padding around is always the issue with that, isn't it? So what you normally did was like a width of 98%, and then you hope the 1% is enough. But as a percentage is always of the parent element, if the parent element has no space anymore, there's no padding at all in there. So what you do instead is you do a width of calc 100% minus 1 em. 1 em is one character, so you calculate what does 100% of that box minus 1 em on, which is 0.5 em on each side, what is the width of that? Render that browser. You don't have to think about it, you don't have to know what that is. The same way when you need 6 boxes next to each other, you do a calc 100% divided by 6. Of course you could do that in your head, or like put like lots and lots of things in there, but think of the maintainer. If the next maintainer needs 8 elements in there, he has to change the number 8, not do the math in their head again, what 100% divided by 8 means. So calculations in CSS are the first thing that went in there that made CSS much more dynamic, because originally it was never dynamic, it was just applied and that was it. You cannot change it in CSS itself. These are supported all over the shop except for Opera Mini, because Opera Mini is a streaming browser that takes your HTML, CSS, and JavaScript, bundles it up into one string, and sends it down to the browser. This is to the end user's phone. This is in countries where connectivity is really, really expensive, really, really bad, or if you're on roaming and you basically want to do that. So there's no way in Opera Mini to do something after the page has been rendered. That's why all of these things are not supported. Media queries are another big thing that have been around for ages now. What media queries allow you to do is apply different CSS according to things that are happening on the screen. So if in this case, if it's a max width of 600 pixels, then actually don't display that sidebar element, because you only want to display it in a lower image, in a smaller viewport. You can do that on link elements, you can do that in the styles itself, and you can do things like if it's portrait, if it's landscape, if it's handheld, if it's print. These add media queries are very, very powerful to only do things when a certain thing is matched. They can get quite hard to maintain, but we're going to come back to that later because there's a clever way of doing it. But they've been supported for ages in every single browser. So don't just try to read out in JavaScript how wide the screen is. Use a media query for that because it's much more reliable. And there's not a browser that doesn't support it except for, IE10 is dead as well, so it's all good. There's also a sister property in JavaScript for that called match media, which I don't see people using a lot. So the problem with CSS media queries is that even if you have like, okay, you got 12 images in there saying like, if it's 2000 pixels, show that image, if it's 400 pixels, show that, and so on and so forth, the browser loads all of them and then only displays one of them. If you use match media in JavaScript instead and then create the image and replace a smaller image with it, then you don't have that problem. But again, this is a way we should use a picture element in HTML instead, because we have those right now. But this is an example to make sure that things only get loaded when they need to, and you have something smaller that gets replaced by something prettier. Media queries with match media are an interesting thing as well. Generated content is something that we keep underestimating, and it's a very strange one because originally I looked at an HTML document, the HTML is in there, and CSS didn't do anything with it. It just added colors, it added fonts, it made it look differently, but it didn't change the content of the element itself. But sometimes you want content that is not in the HTML, and that is just a nice to have, or a pretty thing to do that you don't want to type all the time. And this is where generated content comes in. So an example here is these Q elements where you want to have the quotes in the beginning and the end. So there's a blue one and a red one, don't have to see it on the screen. But it's just like you do Q before and Q after, and you create the content that way. So what that one gives you is a styling handle to do something extra on that element that only makes sense in a styling environment but has no value. A blind user doesn't care if that's a blue or a red quote as long as they know that it is a quote, and they know that by using the Q element. Whereas like you don't want to maintain that in JavaScript, you don't want to maintain that in the HTML with a span with the carries in it, because they're unnecessary. They're only necessary when it's a visual thing to display. And people use that for all kind of wild things. There's a great website called asingledif.com, a.singledif.com, and they do these kind of things. These are all one div element using CSS gradients, using drop shadows, using all kind of stuff in CSS, and generated content around them. So you can create really, really complex visual things without having to change your HTML, without using any JavaScript at all, if you have somebody in CSS who knows their stuff. These are nice to see. Sometimes they're really horrible to actually, in terms of complexity, when you start scrolling the screen and stuff. So these are nice to show people the power of them, but use them sparingly because you don't want to have like an image of like an Ecto 1 on every paragraph or something like that. Again, supported all over the browser front. There's no excuse not to use generated content when it makes sense, because these are things that are visually nice to have. Why should they be maintained in a content management system? Why should they be maintained in JavaScript? Oh, that's such a shame. Okay, here we go. Ooh, animations and transitions. And you know where I'm going with this. These are powerful. Don't use them too much. Don't get too excited about all the cool things you can do with animations, because they're expensive. Not in terms of dollars, but in terms of CPU power and GPU power. And they're also very distracting. So somebody with a learning disability, for example, with blinking and animating and rotating things, will be impossible for them to use your content. And you don't want to be too frivolous with it as well, because if you got a cutesy animation that when something goes wrong, if I see that for the 10th time, I start not trusting your company anymore, but it's think you're taking the piss rather than helping me. So animations and transitions have been defined in the standard for quite a while. And my favorite is transitions, because just by having a transition of transform 1 second, line 13 here, you make everything smoother. So the demo that I've built, that I wrote it like 8 years ago or something, is that I did a little element that when you click somewhere on the page, it puts a ball there. And when you click again to it, it moves smoothly from one to the other because of that transition. I could have done that in JavaScript, but I didn't need to. Just by putting a transition on something, it goes smoothly from one way into the other. And if the browser doesn't support it, it just goes to the end of that animation and nobody gets hurt. And nobody has to load a lot of JavaScript and actually do a for loop and changing and re-rendering and refreshing and repainting every time, because that runs on the GPU by the browser picked for you. Animations is the same thing. You have an animation duration, animation names, and you have keyframes where in the simplest way you do like a from to to, but you can do like a 0%, 1%, 2%, and so on and so forth. This always drives me nuts, because as a JavaScript developer, I always want to put a colon after the from or the to, but it's not the CSS syntax. So that's one thing that, but fair enough, I just don't have a life. Animations are pretty amazingly supported, and they're actually doing their job well. There's also a web animation API in JavaScript if you want to have frames per second control, if you want to have keyframe control, if you want to remove and add keyframes accordingly. But again, this means you're responsible to make that thing work. In this case, the browser jumps through hoops, bends over backwards, and bakes you a cookie to actually make this animation happen, and you don't have to worry about it. Because if it doesn't happen, it still is not in the way of the end user. Whereas if your JavaScript animation in the for loop gets slow and eats up all the resources, you have a half-finished animation. And you never want to see a half-finished animation on the web. They're supported everywhere again, except for Opera Mini, because of the reasons that I said before. The interesting thing about animations and transitions is that the interaction with JavaScript is via events. So it fires events while it's actually, before it's happening, while it's happening, and after it's happening. So you can do like, you can chain animations that way, or you can react to an animation when something was finished. I wrote a few games that just used that. That basically was like one big event handler that just listened to the end of an animation, because at the end of the animation you hear, you get the name of the animation and which element was animated. So that way you can easily sync your animations and create a new one by applying a class to a parent element, for example. Viewport units are a super nice thing to think about. The biggest problem we have with typography on the web is that things need to be readable, but screens might be completely different size, and we don't know what the size of the screen is. So viewport units are newish units in CSS that are not pixels, that are not EMs, but they're actually called VW and VH. So a viewport width is a percentage of the full viewport width. 480 pixel wide screen, 10 VW is 10% or 48 pixels. The difference between 10% and 10 VW is that percentage is the percentage of the parent element, VW is the percentage of the window. So if I now have a diff inside a diff inside a diff inside a diff where I do a 10%, it becomes 10%, 10% off 10%, 10% off 10%, you get smaller and smaller the more you nest it. Whereas a VW will always stay no matter how nested your HTML elements are in this page. Viewport height is the same for the viewport height of the browser. And viewport, there's many things. There's the viewport, there's the document height, there's the browser height. So viewport is basically what's visible in the screen right now. So that way you can use these things to do like sticky footers, sticky headers, navigation that are always wide enough to actually see things. Then there's viewport minimum, which is a percentage of the viewport width or height, whichever is smaller. And so, for example, 10 vbin is 10% of the current viewport width in portrait, or 10% of viewport height in landscape. So you don't want to do different layouts for that, you just use vbin. You use vmax for the other way around, so percentage of the viewport width or height, whichever is larger. What you can do with this is like really, really simple typography that's readable. So again, you use the calc that I explained up front, where you say like font size calc 16 pixels plus 1 VW. So your font will always be 16 pixels, no matter what the resolution is, plus what's extra available. So on bigger screens it will be bigger, on smaller screens it will be smaller, which means the length of the sentence stays the same, which is how we read as humans. You then do a line height where you have like the vertical measure as well, and then you probably want to do something like a 1.2 EM and 3 VW for an H1, and if it gets too big, if the website is really huge, then stop it at 50 pixels because you don't want to have a 3000, or in this case a 3000 by 2000 resolution with a 400 pixel header. That's just far too much space used just for the headline. So what this looks like in a browser is like if you resize the browser, the font always stays readable no matter what the screen is. In this case, we didn't limit the length of it, so that sentence length is not the thing. But you can see like it's not becoming too big, it's not becoming too small, it always stays readable. And that's a very simple way of doing that rather than having to do that in JavaScript or whatever we tried to do in the past. A quick thing about this, every CSS developer and every JavaScript developer keeps doing this. We keep resizing our screens to watch our different media queries being applied. We shift things around. Nobody ever does that. So if there's problems in between the different sizes while they're changing, don't care. End users have a resolution and they don't resize their browsers all the time and see until they can break it. Only developers and QA people do that. So make sure that the thing works in a certain state, but the in-betweens are not that important. So when people do media queries with like 500 breakpoints, this is actually not helping anybody. Make it as simple as possible. The less code we put on the web, the better. Viewport units are supported in all browsers. Edge has the problem that vmin and vmax is not supported yet. Please go and complain to us about this, that we fixed that. It's in the making, but we need more people to do it. That's a general thing. If you see something not supported, complain, complain, complain. Or even better, use it. Use it in production. Show us how your website is terrible because we're not supporting it. So the more we actually get real use cases of the web, rather than like, oh, this should be because the other browser does it, the more we actually can put engineers out and actually get them onto the job. We're also a software company, like Google is also a software company, Safari is a software company. We have a limited amount of resources. We don't have a cloning machine for developers. We actually have to make developers do things that are important. Now, Flexbox, talking about flexible boxes, oh God. Flexbox is basically what you always wanted CSS to do and you never wanted to understand. This is what we did with layout tables. So you can do almost everything in a horizontal or vertical display of an element. So in this case, there's a massive div here, or it's actually the body, and you can do like align these things to the left, to the top, to the bottom, to put the space in between them, put the space around them, align them all to the left, align them all to the things, change their order. So the order they are in HTML does not mean necessarily the order that they're being displayed on the page. My personal blog does that for my header up there. I mean, I have my picture in the middle of it and the text around it, but in HTML, it's first my picture and then the text. So the order for a blind user makes total sense. For a visual user, they get a nice interface when there's enough space on the screen, and if not, it just falls back to a list of links again. So Flexbox is the thing to use if you want to actually align things in a certain viewport, or if you want to align things in a certain other element. It's the better replacement for absolute positioning in a relatively positioned element we had before. There's a great game if you want to play with it, if you want to learn how to, or that's when I do teaching for children. Flexbox Froggy it's called. You basically change the code around to put the frogs onto these lily pads, so you learn the syntax of Flexbox that way. There's a great talk by a local hero, Zoe Gillenwater. She, 2 years ago, she actually spoke at Smashing Conf about this. That's her on Twitter, where she actually shows how Booking.com is using Flexbox. And back then it was like, oh my God, you use Flexbox already. Nowadays they don't even bother anymore saying it. But she also shows how it falls back to sensible interfaces when Flexbox is not supported, rather than jumping through hoops and doing all kind of positioning. Flexbox is again supported by all browsers except for IE, and that's that. Now, if you want to go even wilder, there's CSS Grid. CSS Grid is the coolest thing right now in CSS. There's every talk, every conference is about CSS Grid. I thought about talking about CSS Grid exclusively today here, but then again, I thought it might bore people if we only talk about one thing. CSS Grid is much like Flexbox insofar that you define a grid in your page and then you position elements around it. But it is so flexible. It's incredible what you can do with it. You can name the lines. You can change the order of the grid elements around. You can shift things in there. So instead of me going through lots of syntax and showing you what it's done, there's a great resource called Grid by Example, which gives you copy and paste layouts if you want to use CSS Grid. And it also gives you video tutorials, what they mean and how they function and how they interactively change around. So it defines what the FR unit means, what a repeat notation is, and so on and so forth. The notation can look a bit daunting, but once you got a head around it, it's actually incredibly powerful. And if you don't want to learn it, fine, just understand that this is there. You don't need a CSS grid system like 960 CSS or whatever others we had out there, because browsers support that now. Again, there's a game as well, if you want to learn it, called CSS Grid Garden, where you have to move the water to water the carrots, and that's pretty amazing as well. 2 great talks to look about that. I mean, I'm pushing talks here because I get this stuff recorded. I spend time writing my talks. All this shit is for free on the web. Use it. Use these things to teach yourself new things rather than asking your boss to go to a CSS Grid training. These things are available. Download the videos, sit down in the office with a coffee and cookies, watch one of those talks with your colleagues, and then discuss how you can use it in production. Why not? So CSS Grid Layout by Rachel Andrews, she's been banging on about CSS Grid Layout for 5, 6, 7, 8 years now, and nobody believed her, but now we have it. And Real Art Direction for the Web by Jen Simmons from Mozilla as well. That is another great talk to learn about the power of the grid. The interesting thing about CSS Grid is it was a Microsoft specification. It was actually first supported in IE8, I think, and as it was Microsoft, nobody liked it. Grid layout works everywhere. It's still prefixed in some of the older IEs and Edge, but again, we're working on that because we actually have a few bugs in the standard committee that need to be fixed first. The disappointing here is Android browser, and I have to look that up. I don't know why that is, but this is really bad. Like this kind of stuff I don't want to have. So why is there a Flexbox and a grid? They seem to be doing the same thing, right? You align something along a grid. Well, Flexbox was designed for layout in 1 dimension, either a row or a column. Grid is meant to be in 2 dimensions, so you can position things everywhere, whereas like Flexbox is there to lay out one element according to what you say it should be doing. So Grid should use Flexbox for its inner grids as well. So that's not a bad idea. They don't work together. They don't work against each other. Now, CSS custom properties is the last thing that I want to talk about. And they're the really, really cool thing that finally is in CSS as well. When people started using Sass instead of CSS, they wanted variables. They wanted to define a company color and then use company color and not know what the company color is, because if it changes every 2 months, I have to do a search and replace on all my CSS. I have to find the things that is not fun to do. So what custom properties do is allow you to do a dash dash first color, and then you call it with var dash dash first color. That could be any CSS or any content that is a valid way of defining something in CSS that you can start reusing. And one powerful thing to think about in this case is like, you saw calc before. What if I want to calculate on a calculation? I cannot nest calc in CSS because that's not what the CSS syntax is meant to do. But I can use variables for that. So I can say a width A is 100 pixels, and a width B is the calculation of var A minus width of the width A divided by 2. Width C is a calculation of the width B divided by 2, and then you set the width to var width C. So you can nest calculations using custom properties. But that's only the tip of the iceberg. Custom properties really, really make a lot of sense in CSS because they allow you to name things that you weren't able to name before and to reuse things across your CSS that you don't want to have the same way in 10 different places. That's like bad coding. So if you want to learn everything about that one, Lea Baru gave an incredible talk, CSS Rebels var subtitle, where she goes through all the things, gives you like 10 takeaways. She wrote a big blog post about it as well. So for example, in this case, I've got a gutter of 2 pixels on the root element, and in a section, I say like margin gutter. So that gives me 2 pixel margin around all the section elements. But if a min width of 1000 is, then the gutter should be 10 pixels. So you can redefine those variables and overwrite them inside a media query, inside a calc, inside all the if statement-y things that we have in CSS. So that's a very powerful way to define something and reuse it rather than like knowing the value all the time. They're well supported in all browsers. IE 11 doesn't do them at all. I actually don't know what the edge problem is right now, but I wouldn't be worrying about it too much. They will go away as well. I have to look that up. CSS feature queries are a thing that is basically an if statement for CSS. So you can do a if add supports animation name test, then we know the browser supports animations and we can start defining the keyframes. So that way you never have keyframes that are just unnecessary in your CSS in this case, and you make sure that all the things are supported right now. You can also do a not supported, so you add support not is then the things that the browser doesn't do, so you give a fallback for the browsers that are worse. But this is kind of crazy because you're actually building for the past. You're building for a thing that is becoming your maintenance job rather than the browser makers making sure that their browsers support these things. Feature query supported in all browsers but IE, because there's no new features for IE anyways. Now, we talked about CSS and JavaScript, so like why use one or the other? I always think it's a very, very powerful thing to make them work with each other. JavaScript is there for me to interact, to react to what people have done to my page, or to react what data came in, what things have been loaded, and CSS is there then to define the interface that gets rendered in the browser without me having to know how the browser handles it. So, of course, the old school was JavaScript, CSS, and HTML all have to do different things. And when you work in a space like a React component, when you work in a space that is a modular environment, then this is all out of the window. I mean, you're already relying on client-side routing. You're already relying on an interface that gets built not the way HTML was meant to be built. So in the case of modules, you have a button that needs to have its JavaScript, its CSS, and HTML only for that button because you want to reuse it across the page without other styles bleeding into it. And this is not where CSS is excelling. There's standards coming. We've been trying it. It's not really that easy. But when you look at like web components and you look at componentized systems like React or Angular, it does this under the hood. So I'm not saying that CSS can solve everything, but I think when it comes to page layouts, when it comes to documents, when it comes to full applications rather than module-driven applications where you know it, CSS and JavaScript working together really, really does the job. And you use CSS when you can using the things that I just showed you. Don't read out inner width of a browser anymore. You don't need this. We've got lots of CSS to deal with that kind of issue. If you need to communicate with CSS, consider changing custom properties, because you can change them on the fly. And if that's not an option, apply classes to parent elements using class list. We have class list now, not class name anymore. That's very powerful as well. And as a very last resort, you can alter the style directly. But this is a very, very bad way of interacting with the browser, and it's actually, in most cases, intercepting the browser's rendering. So again, from that talk, element style get property value, -- foo gets the property from inline style, get computed style, get property value, gets it from wherever, and you can set a variable on the inline style with JavaScript as well. So what can you do with this that is so powerful? You can do all the things that JavaScript can do that CSS cannot do, and give it to your CSS to do something with. An example that she has in that talk is that you have a mouse move, and on the mouse move it gives me the mouse X and mouse Y, and creates a custom property in CSS. So in any CSS, I can now position things at the mouse pointer without having to do that in JavaScript any longer, which we used to do since the HTML days. So this functionality becomes available to CSS, and my CSS just does the rendering for me. And this was impossible to do before we had custom properties. So if you do like a translate X, -- mouse X, var -- mouse X, and I translate Y -- mouse Y, you actually position the thing where the mouse is right now, and every time the mouse gets moved, this custom property gets updated and the CSS renderer does the job for you. Every style change has consequences though, so if you start messing around with styles, not with custom properties, but like width, height, position, blah, the browser needs to do something. And there's a great website called CSS Triggers by Paul Lewis and Das Surmer from Google that did all the research for you to say like what gets affected by which thing. So make sure that when you wonder why your interface is really, really slow, that's a great resource to tell you what's happening under the hood and why the browser is actually starting to start the fan and gets annoyed with you. So CSS is much more reliable than it used to be. And in the CSS, in the W3C specifications, any of them is defined as users over authors, over implementers, over specifiers, over theoretical purity. So what comes at the end of your end user is what needs to be bulletproof. So if CSS can take a lot of pain away from you, consider using CSS rather than having the full control over the interface with JavaScript, because then you also have full responsibility. Our users deserve interfaces that are smooth, reliable, and don't kill their batteries. That's the biggest issue on mobile. So consider CSS a bit more. You can be lazy and you can build on the work of the community. There's a huge community around CSS, discussing, fixing, building things for you. There's a lot of stuff that you can use, which I've done here to a degree as well. Because here's a few super inspiring and highly active CSS folk. If you want to know what's going on in CSS, here's a list of people that I follow, and I will write them up in a blog post as well that inspired me a lot to give this talk. So there's Chris Coyer, who does CSStricks.com. It's basically the best website right now to find out what's going on in the bleeding edge world of CSS application, not standards, but how to actually use CSS. Rachel Andrew is the goddess of CSS grids. Anna Tudor does a lot of math animations with CSS only. They're not really that useful, but they're really, really pretty and show you the power of what CSS can do and animations can do. We love Anna because her stuff is so brutal to the browser that we're actually we're testing our CSS engines against it to make them faster. So that's a very, very nice. Her code pen is really, really exciting to look at. Iri Aderinokun is a newcomer. She actually does that Bits of Code blog, where there's lots of very simple explanations of new stuff that's happening in CSS and also in JavaScript. Zoe Gillenwater, as I said before, did the best talks on Flexbox, and she's local here in Amsterdam. Brad Frost does the atomic design stuff. Rachel Neighbors is a colleague of mine. She's actually here today and speaks on Friday. She's an animation expert, CSS animations and web animations. Una Kravitz does talk a lot about blend modes of CSS and filters of CSS, and also lately a lot about Vue.js and doing graphical animations in CSS. Leah Baru is basically, as I said, she always takes one CSS thing and makes a 1-hour talk out of it that analyzes it to the nth degree and explains to you how to use it. She can get very stroppy with people when they communicate with her about like, why is that a thing I should be using, but her talks are really, really informative and really exciting to listen to. She's a researcher for MIT, so she's very thorough in her research about her stuff. Sarah Sweden is a web developer from Lebanon, and she did the layout for Smashing Conf, for the new Smashing magazine. For that magazine, they have a lot of talks about all the details that they put in there and all the things, how they make it work very flexibly, very accessible. So that's an exciting person to follow as well. Sarah Dresner is again a writer for CSS tricks. And she's been around for quite a while as a developer that used CSS always in a way that is very scaling to all kind of users and all kind of products. And Jen Simmons is working in Mozilla, and she talks a lot about art design on the web using all kind of new technologies. So there's a lot of people to follow and just listen in on. They always send cool stuff around, so think about that when you're thinking about CSS, and that's all I got time for, so thanks.